This video shows you how to conduct a Pearson correlation in SPSS. The Pearson correlation is used for variables on an interval or ratio level. If you have ordinal variables or severely skewed distributions of your variables, you might want to consider rank correlations such as Spearman or Kendall-Tau, linked in the video description. To conduct the Pearson correlation, go to Analyze, Correlate, Bivariate. I will put 3 variables into the analysis: height in centimeters, weight, and income. If you wish, you can request means and standard deviations for the variables under the Options button. If you need the covariance, you can check cross-product deviations and covariances. In regard to missing values, you have the choice of pairwise or listwise exclusion. The latter only comes into effect if you correlate more than 2 variables. Listwise means that rows with any missing values are removed completely from calculations. Depending on the analysis you run, this can be useful. Bootstrapping and confidence intervals are usually not required, but can be requested under the respective buttons. The Pearson correlation coefficient is already pre-selected. In case you have formulated one-sided hypotheses, you can request the corresponding one-tailed significance testing below. Finally, the flag significant correlations option is ticked, which will help identifying low enough p-values, especially in larger tables. Since the correlation table is symmetric, you can request only the lower triangle by ticking the box and also remove the diagonal. Those are all relevant options, and you can request the results by clicking OK. I will skip the descriptive statistics, they speak for themselves. The correlation table below shows, as requested, 3 correlations. Generally speaking, focus on the p-value first. If it is below the predefined threshold, for example 0.05, the null hypothesis can be rejected. Reminder, the null hypothesis assumes no correlation, neither positive nor negative, between your 2 variables. I can observe one p-value of smaller 0.001 and can therefore reject the null hypothesis for height and weight. The Pearson correlation coefficient for this pair is positive with 0.669, showing a positive association. This is of course reasonable because larger human beings usually weigh more and the other way around. Keep in mind though that the correlation does not imply causation. Furthermore, a small p-value does not tell you about the magnitude of the correlation, aka effect. The magnitude of the correlation is the correlation coefficient itself. Compare it with existing studies or use research field-specific thresholds to classify your correlation. If neither exists, you can fall back to Cohen 92, a power primer, and use the thresholds on page 157, 0.1, 0.3 and 0.5 for small, medium and large effect sizes. My correlation of 0.669 is well above the threshold of 0.5, making it a large effect according to Cohen. The other 2 correlations, height and income as well as weight and income, show no low enough p-values.